So this is section 5.5, and this is theorem 5.5.1. And this is a pretty neat thing. Okay, so if z is on the line through two complex numbers or points in the complex plane, z1 and z2, then one thing we already know, this has been mentioned, z is equal to 1 minus t times z1 plus t times z2, where t is actually just a real number. But if you rearrange that, then you can write this and use absolute values. We have that the absolute value of z minus z1 over z minus z2 is equal to the absolute value of t over t minus 1. And now that, of course, is if z is not equal to z2. And then a second formula, z minus z1, that absolute value, over z1 minus z2 is equal to the absolute value of t. So that's kind of neat. Okay, they may have the proofs of that in the exercises, right? If I'm gonna go about trying to prove something like that, right? I've got t over 1 minus t. So, you know, if I'm going to try to get to something like that, right? I see a z minus z1 and a z minus z2. So it seems to me if I'm going to prove 1, what I'm going to start with is, you know, I've got that, and then I'm going to write that as 1 minus t times z plus t times z is equal to the 1 minus t z1 plus t z2. And so I'm going to start there and, you know, pull together like terms and all that stuff, and then toss the absolute values in as I need them. But that, I think, is the key to getting that done. And then on 2, what do we have? We got a z1 minus z2. So there, I just think, you know, because that's got a z1 minus z2, I'm going to multiply through by z1 here and move the 1 times z1 over with the original z and factor out the t for the other ones. And that's how I think I'd go about trying to prove 2. Okay, so let's see. Oh, they do mention circle equations. So so let's go ahead and toss that in. A circle. And they say, oh, that's the equation z minus z0, that absolute value, equal r. You know, for some z0 element of the complex numbers, and r greater than 0 is a circle in the complex plane. Okay, and the center is z0 and the radius is r. And you know, so does that make sense, right? Well, okay, let's just take a z equal x plus iy, and a z naught equal x naught plus y naught. Why not? Huh? Sorry. And if I look at that absolute value, right, of z minus z naught, then that is the absolute value of x minus x0 plus I times y minus y0. But then that is just the real component, x minus x0 squared. Well, let me do this squared so I don't have to throw the square root in there. And then plus y minus y0 squared. And then that would equal, since I squared them, r squared. And yep, that's a circle. Okay, so there is, you know, it looks kind of funny because there's nothing, you don't notice anything squared there, but you know, you certainly get a square in the components when you actually do the magnitudes there, the modulus. Okay, so we'll stop that one.